Yeah, Vaishnavi, are you going to present?
Yes, sir.
Okay, you can present. Any technical issue, Vaishnavi?
Yes, sir.
Okay, then meanwhile, Sirisha, can you present? Sirisha T.
Yes, sir.
Okay, continue.
Yes, sir.
And Pradeep, are you there?
Yes, sir.
So I think my guess is by the end of now you are in final year, na? So by the end
Yes,
of
sir.
final year, if you attended any campus interviews or offline interviews, if you get chance, definitely you will get selected by the end of final year itself. Okay.
Yes, sir.
Okay, right. So for that,
Thank you.
yeah, for that, whatever the support you want, you can ask me. Maybe I will give you some codings also. Previously you asked, but you are the correct person to ask, but you asked in the wrong time actually. That time I was in some other issues. Okay, so later you can
Yes,
remind me. I will give you whatever the technical support you want. I will give you. Okay.
yes, sir.
Okay. Yeah. Okay, Sirisha, start.
Screen visible, sir.
Yeah, yeah, visible. Yes, both of you
Good
are
evening,
visible.
sir. Good evening, sir.
Yeah, good evening. Continue.
Good evening, sir. Today topic is I am going to explain is Boolean algebra. The first introduction of the Boolean algebra is it is used basically in mathematics to deal with the binary values like 0 and 1. So it is the branch of mathematics. It deals with logical operators on binary values like 0 and 1. It also means high or low and also true or false, etc. So Boolean algebra uses some operators like basic operators and or not gates. These logic gates are used to model logical designs forming the basis of all digital systems. And also Boolean algebra is used for the efficient creation of logic gates and combinational circuits and memory units in hardware. And also it used in the electronic circuit theory and the foundation of digital circuit and etc. So I am going to explain next in Boolean operators that are and or not gates. First we are going to explain is AND gate. So the AND gate means it's if you apply both inputs as one and also output becomes one. If both operands are true value one, then only output becomes one. This is the AND gate. If is there any zero in the output becomes zero. So this is the symbol of the AND gate, and then truth table of the AND gate, and this is the operator. And also we use this symbol also we use it as a AND gate, X AND gate symbol. Why? So then and next we use a OR gate. The OR gate means if the output is one, at least one of the input is zero. So if we applying inputs are zero and one, if the inputs there is one value as zero, then output becomes, and if there is one value as one, then output becomes one. And this is the symbol of the OR gate, and this is the truth table of the OR gate. And then this is the operator of OR gate. This is also the symbol of OR gate we use actually in simplification of Boolean algebra expressions. And then we use a NOT gate. So the NOT gate means if you apply zero, then output becomes one. If we apply one as input, then output becomes zero. So it is the reverse value of the operand. And this is the symbol of the NOT gate. And this is the symbol of the OR gate. we use it actually. And then this is the truth table, and then this is the algebra operator. So this is the oral diagram of the not gate. And then Boolean algebra, we used some laws. There are some fundamental laws. I am going to explain few of them. And then the first law is commutative law. So in commutative law, if we use under OR gates, so first if you apply two variables, then output then does not affect on the result output. If we apply anything for if first for applying and get a into b, so this is means in the into symbol is like this is the means and gate symbol, so output also b into a. If we apply a as 1 and b as 0 and b is 0 a as 1, the output does not affect on the result, because if input is changes, here is 1 into 0 or 0 into 1, the output becomes as same these two expressions. So that means commutative law is does not affect on the output. If you apply reverse also, does not affect on the output. For OR gate also, a plus b equal to b plus a. So the example, if you apply a as 1 and b as 0, and also b as 0 1, does not affect on the output. Output will be the same. And then the second law is associative law. So if we applying two or more variables, that also combined and using the under operators, if this also grouping, then in this we use two or more variables, more than two variables also we use. This is also does not affect on the output. If we use logically for AND gate, a into overall b into c, and also a into b into c. So if we apply example 1 into 0 into 1, so this expression does not, if we simplify this, the output becomes 0, and this we simplify this, this output becomes 0. And then for OR gate also, a plus b plus c equal to a plus b plus plus c. So 1 plus 0 plus 1. So this means the output is 1. If you simplify this, 1 plus 0 plus 1 means 1, and also 1 plus 0 plus 1. This output also 1. So if we apply anything like this input as reverse also, the output does not affect. This output will be the same. And then third law is distributive law. So the third law is distributive law means if we use and all operations distributive over each other, means if we combined both of this and or operations, like it is similar to how multiplication distributes over addition in arithmetic. So if multiplication we use it in AND gate, and R in OR gate we use addition. So first AND over OR gate is means a into this symbol is for AND gate, and b plus c this is for OR gate. So AND gate over OR gate. So if you simplify this a into b, this means this is AND gate plus a into c, this is also for AND gate. This plus means this is OR gate. So and over OR gate. This means if you apply a as 1, b is 0, c is 1, and if you simplify this, the output will be the 1, and then we r will be r over AND gate. So if you first in this we use OR gate, and then we use AND gate. This also first OR gate, AND gate, OR gate. So if you apply 1 and 0, 1 as a, b 0, c is 1, so the output will be the same. Into this values, output will be the 1 value. And then the next law is identity law. So in this identity law, if you any variable and if you use and, it is ended with 1. If you take r, it is ended with 0. It's if you want to take any value, it will end with the original value itself. If we apply for AND gate is a into 1 is equal to original. So original value itself, the value itself is reflects as output. So a into 1 is equal to a. So if you apply example also, if we apply 1, it will become 1 into 1 as 1. So if what we applying is coming as the output. If we apply here is 0, then also output becomes 0. For our gate, a plus 0 equal to a. So example, we applying a as 1, the output becomes 1. And also, if you apply a in place of 0, so the output becomes 0. So that means this is the identity law. And then next we going to explain is a complement law. So complement law means it involves the negation of a variable. So negation means if you complementing a value or a variable and provides the result when a variable is combined with its complement. So if in complements la a variable and also complements of that variable is the value. So this law so is a if complement law uses AND gate will always zero. So for AND gate we applying complement law, the output will becomes always zero, and we applying OR gate will complement law we use always output will be the one. So first we for AND gate the expression will be a into a complement. So in this AND operation we are applying and this complement in a value we are applying complement. So if we are using AND gate in the expression the output will be the zero. So if we example I take one a as one. So we are applying here is one complement. So one complement means it value becomes zero. Or we are applying zero means here becomes one. So the output will be the 1 into 0. It means 0 output. If we are applying it here as 0, so 0 complement is 1. So 1 into 1 is 1. The output becomes 1. So that's like then for OR gate we using a plus a complement equal to 1. So here OR gate is always output will be the 1. So if you applying 1, example a as 1 and 1 we applying is 1 complement equal to complement is 0. So 1 plus 0 equal to 1. So this is the complement and inversion law. So the inversion law means if we apply complement and then first we applying the complement of that variable, and then we also apply complement of the whole variable. So that is the complement of that variable of any variable. So if we applying that two times of complement, the output will be the original value itself. So if you see like this, a complement overall complement equal to a. So what we observe is this a is the we applying value. So the output will becomes a original value itself. So example we apply I apply one complement overall complement. One complement means one complement is 0. So then applying 0 as complement, its value is 1. Then the theorem is so in Boolean algebra we use basically De Morgan's theorem. It will be very easy, and then so we use into two operations like first is the negation of AND operation is equal to the OR operation to the negation of operand. It means if we use AND operation, so that's like A into B. So it means AND operator whole complement is equal to the OR operation. So if we apply A as 1 and B as 0, whole complement equal to. So if here you are applying AND operation and here we are applying OR operation. So this 2R will be the equal. So this value will be equal. This value will be equal. The output will be the 1. And then second operation is then here is AND operation is equal to the OR operation. Here is OR operation is equal to the AND operation. So here the example is A plus B whole complement equal to A complement into B complement. So I take binary values 1 and 0. So that's why A as 1 and B as 0. A complement into B complement equal to A complement is 0, 0 complement is 1, and then output will becomes 0. So again, And then I will take example of one expression in Boolean algebra. So in Boolean algebra, A into B. So the A into B is operation. So first plus means it is OR operation and C into. So this means AND operation. This not gate operation. This is the symbol. So first I take A value as 1, B value is 0 and C value is 0. So I'm solving one by one. A into B AND operation I will use. In AND operation in truth table what we if you apply both values as 1 then output becomes 1. So if I take both values as 1 that's why output will become 1. So then C into not get of D, negation of D symbol. So if I take C as 0, D as 0. So if you apply D as not D value 0 as not gate, so 0 complement is 1 value. So already C value is 0. So 0 into 1 is means 0 into 1 is 0. So if I apply values and then all I completed A plus B, A into B. Value is then I simplify this 1 plus this symbol plus then I simplify this 0 is this and 1 plus 0 is 1. This is the expression example of algebra. And we use some of the applications in Boolean algebra in daily basis or digital electronics in our subjects. First, this is digital circuit design. So, if you use a digital circuit design, is simplifies the design of the combination and sequential circuits that we use like adders, multiplexers, flip flops, registers. That's all right. And then logical expression simplification. If you use minimizing of number of logic gates and then improving of circuit efficiency and power consumption, then that time we use also Boolean algebra and error detection and correction. So if you use error detection and correction in Hamming codes, parity codes, like that, and digital signal processing. So if you use Boolean algebra in digital signal processing, if you processing the digital signals for encoding and transforming the audio and video, that's like, and cryptography and security systems means cryptography means it encrypts and decrypts the data of the circuit and security systems in digital circuits. That's about sir. Thank you.
Yeah, completed, huh? Sirisha, your voice
That's completed.
completed. Okay, good. At the end, your voice cut. Okay, good. Good presentation.
Completed,
So,
sir.
yeah, good presentation. You prepared the PPT well.
Completed, sir.
Yeah, okay. Now, are you getting my audio?
Sir.
Getting, huh? Okay, okay.
Yes, sir.
Okay, maybe network issue, maybe your voice is cutting. Anyhow, so it's a good
Yes, sir.
presentation.
Yes, sir. Getting, sir.
Yeah, it's a good presentation. You prepared the PPT well and you covered whole Boolean algebra laws and everything. In the PPT, some few points I will highlight. Suppose you mentioned because of audio issue, I am only explaining network issue.
Ah,
One is inversion law, another one is a complement. So there is very good clear difference you explained. Involution indicating if you take a variable and again complement, double complement, it will become same. That is inversion law. Okay. And if you take complement law, and or operation also involved.
sir.
So
The
but
original value itself becomes. Yes, sir.
yeah, and or involved in the complement law. But and or
Yes,
that
sir.
terminology not there in the inversion law. Even complement inversion we generally treat same, but in the law
Yes, sir.
wise, yeah, in the law wise there is very clear difference. Okay, that is one good point. And when you presented that loss also in the starting, you used Venn diagrams. Once go to Venn diagrams, that is a good thing. So sometimes you may get questions in terms of Venn diagrams also. So I suggest everyone to practice Venn diagrams also. Okay, na? And some symbols also. Suppose for OR operation there is a V symbol. For AND operation there is a cap symbol. Okay, generally we don't write that kind of symbols, but in the
Yes, sir.
standard books that kind of terminology is there. See here, cap symbol, bigger cap symbol, smaller cap indicate that XR, but here see bigger cap. Okay, that XR cap, it will come on the top position like a power like that. Okay, and some other symbol, union intersection also, U symbol, intersection symbol, that also. Okay,
Yes, sir.
intersection indicating AND operation, union indicating OR operation.
Undegated.
uh, and there is a rising arrow, falling arrow symbol
Ah,
also there.
excellent.
So rising
Yes, sir.
arrow, I think, as I remember, NAND operation, falling arrow NOR operation. So that kind of terminologies and Venn diagrams also, everyone I suggest to practice. Okay, overall it's a good presentation. Okay, anyhow, Vaishnavi, you can give presentation tomorrow in your flexible time, because today now at 6:30 I have system relaxation. Okay, na? So tomorrow you can give, and remaining people also. Uh,
Really.
okay, na? In your comfortable time you can give, no problem. You can inform me tomorrow. Okay, right. So with this, our today presentation is completed. I hope yes, you got some new points and you got some practice also, especially. Okay, right. Good. I'm leaving.